Hi everyone, welcome to section 8-9, the final section of chapter 8, which has been very long, and a section that I like to call, as I have in the past, a short cut section. So I don't know if you remember back in, I think it was section 8-4, when we were multiplying things. I said this is a shortcut section. You can always do the FOIL method. It might even look familiar if you look at this problem that's kind of in the middle of my page here. Remember I said the only thing you have to do is write out that y minus 7 2 times because the squared tells you what it is. But we can just go ahead and do FOIL or distributive property. So there is a special name for this green highlighted binomial. It's called a perfect square trinomial. So it's a perfect square because it's got a square second power on it, or we could square root it. A trinomial that's a square of a binomial. Well, let's look at this the multiplying way first, and then we'll look at it the factoring way second. So first of all, if I've got a y minus 7 to the second power, like we said, we're going to write that out as a y minus 7 times a y minus 7. Now, I know that we're not multiplying anymore, we're factoring, but let's get this to the trinomial so we can see. Our answer would be what I highlighted. So when I do this, I've got a y squared minus 7y, another negative 7y. Remember how we could double that? They don't cancel out, same signs, and a positive 49. So when we do the math, we end up with a y squared minus 14y when we combine like terms, plus 49. So now, of course, I'm going to give you that y squared minus 14y plus 49, and I'm going to say factor that. Well, if you notice that 49 is a perfect square, and if you notice that the middle term is double the product of the others, then you can do a shortcut. However, you can always use your factoring options, which is what I do. I don't really usually remember all this business. So notice, now I'm going to highlight in yellow over here. If I gave you this problem to start off with and said factor that, well, we're all smart enough to see that I already put that on the board and I did the multiplying and I know that that's going to be a y minus 7 quantity squared. Well, the shortcut is to notice the square root of 49 equals 7. The square root of y squared equals y. If you multiply these guys together and then double them, we've got that center term. And then we'd have to make that 7y a negative in order to make a negative 14y, which tells us that it would be a y minus 7 quantity squared. Did everybody follow that, right? That's really wonderful. However, here's my advice to you. I would do my factoring option. Uh-oh. I lost number 1. Number 1 says to do a product sum table. If you're making a square, if you do the square method, you're probably just going to do the square method. If you're a product sum table person, this is going to be a nice little shortcut. So here's what I prefer. If you're a product sum person, do your product sum table. So if we do a product sum table over here, what multiplies to a times c but adds to b? Well, a times c is 1 times 49. Adds to b is negative 14. What numbers will multiply to 49 but add to negative 14? Well, 7 times 7 is 49, right? But how do we get those guys to add to negative 14? If we make them both negative, we add up correctly. If we make them both negative, we still multiply to a positive 49. So notice I got negative 7 times negative 7. So step number 2, it says if the values and signs are identical, the 7s are both negative, you don't have to break apart b. you can just jump ahead to the shortcut, factored solution, the square root of the first, excuse me, the square root of the second with a quantity squared. You'll get the hang of it. And we're going to do the product sum table in this problems because that way we can really talk about that. If you're a square method person, make a square. That's perfectly fine. You're going to end up doing the whole factoring problem. This is a little shortcut for product sum table people. So, number one, it says determine whether each trinomial is a perfect square. If so, factor it. Here's the thing. You know if it's a perfect square if you get identical factors, so you don't have to write them out twice because we're lazy. You could just put a quantity squared up there. So, these are nice big numbers, right? For number one, 25x squared minus 30x plus 9. Well, I'm not going to try to determine. I'm going to go over here. I'm going to make a product sum table. Multiplies to a times c and adds to b. Well, my a is 25. My b is negative 30. And my c is 9. Remember, I don't take those x's with it. I just take the number. So a times c multiplies to 25 times 9. What would that be? 225. Check my math. But adds to a negative 30. So you're probably going to get out your calculators. You're going to start doing, 225 divided by 25, 225 divided by whatever. I'm thinking that a 15 times a 15, double check that, but I'm pretty sure that that multiplies to 225. I know that 15 plus 15 equals 30, but I want to add up to a negative 30. So what am I going to do? Make all my 15s negative. So negative 15 times negative 15 is positive 225. Negative 15 plus negative 15 is a negative 30. So now that I noticed I've got exactly identical numbers with signs, the 15s are both negative, I'm going to shortcut my way right out of this problem. I'm going to put myself a set of parentheses with a squared. I'm going to take the square root of 25x squared. Well, we know the square root of 25 is 5. Square root of x to the second is x. So that's where they get that number from. I'm going to go over here. I'm going to take the square root of 9. Well, square root of 9, we all get that one, is 3. And then this little sign right here tells me I have to use a negative. If that were a plus right there before the 30x, I would use a positive. So I've got myself an answer, 5x minus 3 quantity squared. If I factored this using a different option and I said 5x minus 3 and 5x minus 3, would I be wrong? Those are the same, right? Remember, I would make you write those out when we were multiplying. So if you factored using a different option, you might write it out 2 times because you wouldn't even notice, or you'd just be getting your things from your guess and check or from your square method. Both are correct answers. The one just tells me, oh, they probably used a shortcut since there's no work there. So I can see your product sum table, but I cannot see, I don't have any other work to look at. Number 2 is a trick problem. If we're going to do a product sum table, A is 9, B is 12, C is negative 4. So what multiplies to A times C, or negative 36, but adds to 12? Well, 6 times 6, right, seems logical. So 6 times 6, so if I wanted to multiply to negative 36, what do I have to do with my 6's? One's negative, one's positive. But do those guys add up right? That's not giving me a positive 12, that's giving me a 0. This one can't be factored. I wanted to show this because I don't have identical numbers. My 6's, or numbers and signs, my 6's are both 6's, but they're not both positive or both negative. So I'd have to do this a different way in order to factor this, or else say that it is prime. It cannot be factored. 3, however, same numbers, I just switched one side. A is 9, B is positive 12, C is positive 4. So now what multiplies to 9 times 4, 36, and adds to our B value 12? Now we're getting some 6 times 6's, right? 6 plus 6, so everything's positive, everything's a 6, we're good to go. So I'm going to cheat my way through this one. Not cheat, just kidding. I'm going to shortcut my way through this one. First term is a 9y squared. Take the square root of it. So square root of 9 is 3. Square root of y squared is y. My second term, I'm going to take the square root of the c value. Square root of 4 is 2. And will that be a plus or a minus in between my 3y and 2? Remember, this is the part that tells you the sign. Or you know that your 6's were both positive, so you're going to use a positive. Over in example 1, our 15's were both negative, so we use a negative. All right, let's talk about equations real quick. We have solved equations in every section of this chapter. So if we've got a perfect square trinomial, I'm not going to tell you anything different. I'm going to tell you make sure that guy's equal to 0. What's the problem with this problem? It doesn't equal 0. You have to make sure. Otherwise, nothing's going to work out right. Look for a GCF if you can. You've probably heard that before. Factor the trinomial. I don't care if you try to use a shortcut, if you use a guess and check, if you use a square method, if you use a product sum table. It's got to get factored. And what's the big clue? How do you know that something is factored? What does it have in the problem? You're adding parentheses, right? Factored means it's got parentheses. If it doesn't have parentheses, you get a factor. If it already does, like some of those trick problems back in 8.5, then don't do extra work. Then these ones are going to look funny. We're going to do a little example here. Take the square root to get rid of the square. If you don't remember this step or this seems confusing, you can still do it the old-fashioned way. Set each one equal to 0 and solve. So this one's kind of, again, another shortcut thing. If you don't like it, if it doesn't make sense to you, we're going to use this later, but if it doesn't make sense to you now, do it the way that you know it, because you're still going to get the right answer and you're going to start to see, oh, I'm doing more work than I need to. So let's do one example. Let's do number 2. Problem number 2, I've got a 4y squared plus 36 equals 24y. So my first question is it equal to 0? Not, right? This 24y is not a 0. So I'm going to have to subtract 24y, subtract 24y. I'm going to ask you to write this in standard form. And is there any like terms, or do I have 3 separate terms then when I write it in standard form? Keep them separate. 4y squared goes first. A negative 24y to the first, or y the first goes second, and a plus 36 goes last. Now, do I have a GCF? Anything go into 4y squared, negative 24y, and 36? 4 goes into all of those guys, doesn't it? So if I divide everything by 4, or think y, or 4 times what will get me this 4y squared? 4 times what will get me this negative 24y? And 4 times what will give me this plus 36 at the end? Does everybody agree with my dividing or my distributive property thinking? So now I'm going to do product sum table because I told you I was going to do these for this section. I'm going to just totally ignore this 4. I'll put a circle around it. The only thing I'm looking at for A, B, and C is what is inside the parentheses. So it looks to me like my A value, if there's no number in front of the y squared, B value, don't forget the negative on that 6, and C value is a 9. So I'm looking for what multiplies to A times C and adds to a negative 6, my B value. 9's a pretty easy one, right? What multiplies to 9? What do I have to do with my 3's because they're not adding up right? Would you still agree that negative 3 times negative 3 is still a positive 9? Negative 3 plus negative 3 is a negative 6. Identical numbers, identical signs. I'm going to shortcut this thing. So I'm going to do, and you don't have to, you could break apart that negative 6y into a negative 3y minus 3y, group them 2 and 2. So do the same old factoring. I'm just going to bring this 4 down. I'm not doing anything with it, it's just sitting there. So my shortcut is take the square root of this first and put it first. What's the square root of y squared? Take the square root of this last and put it last. Square root of 9. Is it going to be a plus 3 or a minus 3 in that parenthesis? Or we know our negative 3's from our product sum table. So I've got this guy factored. So now I have two options. The old-fashioned way, we'd have a 4, a y minus 3, a y minus 3 equals 0, right? I hate writing out those two y minus 3's. So I could do the old-fashioned way, set each one equal to 0. What do you notice when I set everything equal to 0? Well, first of all, does 4 equal 0 even make sense? So I cross that out. If there's no variables, it doesn't do anything for me. Second of all, when I solve this, I get y equals 3. When I solve this one, what do I get? Matching numbers. You do not have to write it twice. I would just write 3 is my only solution. Kind of crazy. Over here, when we were talking about take the square root, if you like this that I just did right here, use it, if that makes sense to you. Over here, if we're looking for a shortcut, I wish I didn't have a 4 out there, but in order to get rid of a 4 times that, I could divide by 4, right? Those guys will cross out. 0 divided by 4 is 0. Now I said take the square root. We've talked about this before. What happens to a square root and a squaring? Square root and squaring are inverse operations. They undo each other, so I'm just left with what was in the parentheses. And we all know the square root of 0 is 0. Try it on your calculator if you don't trust me. So when I go to solve this problem, I've got y equals 3. If that seems confusing, go back to writing out the 4, the y minus 3, and the y minus 3. As long as you get a 3 for your solution, that's all that matters. Again, this is a lot of work. I mean, it's a lot on the page. If this is confusing, shortcut sections means shortcuts don't work unless you know how to get to the answer. So don't do that method if it doesn't make sense to you. So, lesson summary. Again, do you think you'll take a factoring shortcut for these? Or do you think you'll just factor like the other problems? Make a square, guess and check, or do the product sum table? Why? Why is that? Does it just make sense to you? Does this not make sense to you? Did you kind of figure out the system and the steps so you've got them down and you just want to make sure that you know what you're doing? Why do you think this works best for you? And here's a practice problem. Solve that and factor it first. So first thing I'm going to ask you, is it equal to 0? No, it's not. So I'm thinking you're going to have to subtract 2x from both sides. And I'm thinking we're going to have to write this in descending or standard form, right? So the x squared comes first, a minus 2x plus 1. So now if we're going to solve that, we're going to have to factor, put parentheses in. See if you can use the shortcut if you want to give it a whirl, or see if you want to just make yourself an old-fashioned square or guess and check or product sum table. But at the end, I'll be looking for answers inside those swirly brackets. What does x equal? All right, thanks. Good spending chapter 8 with you. Have a great end of the chapter.